of evolution evidence. Today I will be showing you a clip that encompasses the other evidence that we have to support those theories of evolution. Embryology. Charles Darwin did not really have fundamental ideas of embryology, but we have this clip to show you the development of an embryo. As you can see, as cells multiply, it's kind of hard to know what organism is being developed until the embryo becomes more prominent and advanced. Now that is an example of the embryonic development of a human. And so we're on the second page of our evidence of evolution. Here you have 6 different embryos. Organisms that are closely related may also have physical similarities before they're even born. If you look at A through F, they all look fairly similar. And so in the chart, I'd like for you to go ahead and put a prediction. If you want to predict with me, you can go ahead and predict with me. Based on the video that we just saw, I would probably hypothesize that the human embryo would be embryo E. And then so those are just based on my opinions, my observations. Again, your hypothesis doesn't have to be correct. It can be something that you make an assumption based on information. So based on the video, that is my current hypothesis. Here you have a greater development of those embryos, and so with that development, I think that we can make another more informed hypothesis. I would probably guess that the fish would be embryo A, and perhaps the salamander is embryo B. Just you can kind of see that developing. Still feel like the human would be E, and the chicken would be D, and the rabbit still looks like F, and the tortoise is C. So those are my hypotheses. Again, they don't have to be correct, but probably a little bit more correct or closer to the actual answer based on the development of those embryos. They're looking less alike. If we progress on to our next page, now this is much more conclusive. You're going to fill out the anatomical changes from the early to late stages. So it appears that in the human, we see development of limbs. In the later stages. And as I noted before, we see more distinguishing features, salamander features. Earlier in development. Compared to other embryos. And I think we can pretty much say the same thing for the fish. We see more distinguishing fish features earlier in development compared to other embryos. Features of the chicken develop a little later. In the embryonic stages. And I feel that we could probably say the same thing for the rabbit. I kind of got the rabbit wrong. But I do feel like the rabbit human they look more similar in later stages. Always spell that wrong. And you can see that there. You can see between the rabbit and the chicken, they look very similar. I would probably say that the tortoise, the features of the tortoise developed a little later in the embryonic stages. So these are some things that are observations that I'm making about the anatomical changes from early to late stages. If you have any of your own thoughts to add to that, those are certainly valid. It says, look again at the 6 embryos in their earliest stages to describe the patterns that you see. What physical similarities exist between each of the embryos? Well, in the earliest stages, we can kind of scroll back and look. In the earliest stages, it does appear that A, B, and C, actually it appears that all of them are the same shape. They all have that same tail, and they all have an eyelet. In the earliest stages, the embryos, I spelled it wrong again. Embryos are all the same shape. Shape with the tail and eye position. Okay. I would say though A, B, and C look more closely related than embryos D, E, and F. I would note that as well. So does this suggest an evolutionary relationship? Explain how these embryos can be used as evidence of a common ancestor between each of the 6 organisms. Well, in the earliest stages, all embryos have the same features. This means they're not really specialized, or they don't look specialized. They don't appear to be specialized. Early on. This would suggest a strong relationship because it was difficult to be 100% accurate in identifying individual organisms. At those early stages. Now, if you have an additional explanation, again, that's valid. But that is just something that I would say in the earliest stages, all of these embryos, they have the same features, that same eyelet, the same shape of the head, the same shape of the tail. They don't appear to be specialized. It doesn't appear that there's any differences early on. So yes, this would suggest a strong relationship. It would suggest that because it was 100% it was difficult to be 100% accurate in identifying those individual organisms at the early stages. So this is just another example of something that scientists use to prove their theories of evolution. Embryonic studies is another piece of evidence.